Okay, today I'm back on the regular board. Hopefully we will get rid of some of those stray marks that keep happening and some of those annoying clicking noises, Kaylee, that I'm getting on some of the other videos. So I'm trying to talk loudly enough. Hopefully you can pick this up. Hopefully the recorder on the new machine is a little bit more sensitive and can pick some of these things up. Today we are going to look at the second form for a linear equation, and that is point-slope form of the equation. And the point-slope form is right here. And in this equation, the y sub 1 and the x sub 1 are actually going to be numbers. Okay, you're going to put those in number form, and also the slope is going to be an actual number, the slope of the line. Okay, where x1, y1 is the point that it goes through, and m is that slope. Now, one thing to be careful of, and you'll see this when we do a couple of actual examples of this, that when we put those points, those coordinates into the actual equation, we actually change the signs on them. So y sub 1 becomes minus y sub 1. The x sub 1 becomes minus x sub 1 in the equation. If they are negative to begin with, that is when we would change these to plus, if they were negative to begin with. And you'll see that once we actually start looking at the examples. So we've got three examples here on number 1. We're going to write an equation of line meeting the following criteria. So in this case, we know the slope, and we know the point that it goes through, so we're going to write it in point-slope form. So we start with the y, and then after the y, we have the y coordinate of the point that it passes through, which is the 6. But when we put it into the equation, we're actually going to change the sign on it, so it becomes y minus 6 instead of y plus 6. So just be careful, make sure you are writing or changing that sign when you write the equation. And that is equal to the slope, which is negative 5, times the quantity, and then we have x, and then the x coordinate of the point, which is negative 3. So when we put it into the equation, we change the sign. So that is the equation of that line through the point negative 3, 6, with a slope of negative 5. Now what we did yesterday, and just so you can see how much more work this is, yesterday we put this in slope-intercept form, y equals mx plus b. So then to find that actual y-intercept, we put the y coordinate in for y, the slope in for m, and the x coordinate in for x, and then we solve this for b. So 6 is equal to 15 plus b, and I got 15 by taking negative 5 times negative 3. And then to solve for b, I subtracted 15 from both sides, so that's going to be negative 9. So then the final equation for this line in slope-intercept form, y equals negative 5x minus 9. Now, so quite a bit more work to write it in slope-intercept form. Slope-intercept form has its advantages in certain situations. Point-slope form also has its advantages in certain situations, which is why we show you all the forms of the linear equation, because certain ones have certain advantages given certain situations. Now, for the second one, we're going to do the same thing. We're going to just write point slope form. We're not going to look at slope-intercept form of this at all. So with the point slope form, okay, again we start with the y, and we look at the y coordinate of the point that it goes through, and we remember to change the sign on it, so it becomes y plus 4, and that is equal to the slope times the quantity. Start with the x, and then we add the x coordinate of the point. But remember, change the sign on it. So the equation for that line is y plus 4 equals 2/3 times the quantity x minus 8. And finally, for the third one, we are missing something. We are missing the slope. So in order to write it in point slope form, we need to find the slope first using the slope formula. And again, just a reminder, to find the slope, it's change in y over change in x. So in this case, the two y coordinates are -3 and 4. And you can subtract them in any order you want. I'm going to choose to do 4 minus -3. So then, in the bottom, since we started with 4 on top, I need to start with its partner in the denominator. So that becomes 1 minus -2. So 4 minus -3 becomes 4 plus 3, which is 7. 1 minus -2 becomes 1 plus +2, which is 3. And this fraction does not reduce at all. So we have a couple of possibilities for our point slope form. We could use this point, -2, -3. So if we use this point, use the y coordinate, so that becomes plus 3 in the equation, equals the slope times the quantity x plus 2, again changing the sign on the x coordinate. That is one possibility for the point slope form. If you chose to use this point instead, the point 1, 4, you can use the y coordinate, so that becomes y minus 4 equals 7/3 times the quantity x minus 1. Either one will be acceptable for this equation. That's why if you look closely at the directions, I say write an equation of a line through those 2 points. So, writing that equation, you could have a couple of possibilities, and that's why in the direction I say write an equation instead of write the equation. Any line can have several different point slope forms because it can pass through multiple points. So that is writing the equation. In the next video, we're going to take a look at graphing linear functions that are written in point slope form.